AI devs. It's in the game.
Today I'm going to talk for a while about prompt engineering. I hope that I will not be boring, because this topic might be boring, especially if we will go through the crazy techniques or some techniques that have no proof of working. So whenever you have any question, guys, please ask the question. I will try to answer, or if I will not the question, then let's discuss it later after my presentation or during the break. So maybe some background about me and my journey to this point. So when all of us started to think about generative AI and ChatGPT and GPT model, I was also the guy who was interested to jump on the train. And I remember the moment when I was observing the situation, that people that I'm managing as an AI project manager are observing and thinking about generative AI like something that will change everything, or will change nothing, or is stupid technology, etc. And I would say, yeah. Do you have a question?
I was just calling my friend.
Okay. That's good. Some of the people decided that they will never use, for example, Copilot. And year after, I remember one of my colleagues said exactly a few months ago that maybe next year I will try to use Copilot. So it means that something changed. A lot of us decided that this kind of solution might be interesting for our business, especially if we are in IT. There also was a group of people that, like me, decided that this technology might be interesting, but we need to learn more how to use it, how to harness the power of generative AI for our business. And it was obvious that this type of change in the view of technologies that we will use next years will change everything, especially in our area of AI projects. It was obvious, and nobody is today doubt about this topic. So that's my background for the story. I'm going to give you next slide about my company background. 2 months ago, I decided with my colleague Chris Prusik to start a company that will be some connection of our previous projects or companies. We decided that so far we were interested in automation. Maybe some of you know what does it mean, robotic process automation, RPA. I hope that there are some people who knows RPA, who was doing this. 1 person, 2, 3, 4, 5, 6, 7, 8. All right. So we decided that this situation now seems quite interesting. So far we were doing automates or software robots using RPA, and it was quite interesting. The boom for this RPA things was and disappeared, and today we have generative AI, and in my opinion, everything has changed. We decided that we will build something that we would call a software as a service platform for AI robots deployment. And this presentation is some discussion about the challenges that such companies like mine is facing during this journey. As you can see here, we have some examples of quite poor results of deploying AI robots on the market. These 2 examples here, this one, I'm not going to show what was the company that is the author of this bot. The second one is obvious because here is DPD. So these are examples of wrong approach to deployment of AI robots because it gives too much power to the user, and it will finally result in the situation that you have system that is almost stupid, or directly it is stupid. And your customer will sooner or later share the screenshot from your solution to the internet, to the other people. So it was the situation that we were interested in avoiding. Yeah? We are not interested in doing this kind of robots. Before I will continue, I would like to define a few terms that I would like to talk about. And if you have questions or you don't understand anything that is on this list, please give me information. I will try to explain it better. First, from my point of view, prompt, especially if we are talking about large language models, is a piece of text that will trigger this model to continue the text. Nothing more, nothing special. But the magic, of course, there is. Second thing, prompt engineering. I will talk about this thing on the next slide. What are good prompts? Maybe someone of you would like to answer this question. What does it mean to have a good prompt? Is anybody here? There is a person.
I think a good prompt should provide a specific information and instructions what we would like to achieve using LLM. And usually it also should have some context or some information that help LLM to provide us a good answer.
Okay. Are you okay with the answer? I'm okay. I like this answer. It's too detailed, but it's okay. All right. In my opinion, good prompt is something that will result in a useful response. That's all. You never know what is the good answer if you don't know what are the requirements coming from the business, from your customer. So it's very wide definition. What are bad prompts? Bad prompts are prompts that we think that they will provide good answer, but the answer is poor in quality in terms of it's a messy explanation or messy answer, or it's an answer that has some kind of misleading information. And that's actually is something that we call hallucinations. Or all the answers that you have from LLM model that are somehow pretending that they are correct, but they are not correct. Actually, they are hallucinations, even if they are built from the data that the model was trained on. We assume that this kind of answer will be something like hallucination. Actually, we don't know what is the hallucination and what is the true, what comes from the real data, what comes from the giving yet another next word from the response. Prompt jailbreaking, it's something, I'm not a specialist in security, so I'm not going to give you a perfect definition. However, if you have a prompt and you want to LLM model to give you the response, and you have some bad guy who wants to destroy your system, then he probably will be working on creating a prompt that will somehow make your solution based on LLM model give you an answer or do an action that is not interesting for your customer. That might be a definition of jailbreaking for purpose of this presentation. One question, is everything clear? Am I well? All right, thank you. Good. Prompt engineering. Why I decided to give this slide for this presentation? I know, guys, you are quite experienced people. I'm not going to teach you foundations. It's not this type of presentation. One thing that I observed when I was, I would say, studying prompt engineering last month was that there is millions of stupid prompts and people that pretend that they are teaching others prompt engineering. And I decided that I need to define this kind of engineering because otherwise we will start to do LLM-powered solutions using prompt engineering, and everyone is thinking about prompt engineering like silly tricks to make you $1 million prompt that will make you billionaire in one day just because you used appropriate prompt. It's crazy, stupid, and not this way. So for me, prompt engineering is a connection of two things. One thing is collecting all information and evaluations of the prompts that for the given task will provide you right answer or useful answer. Additionally, I'm interested in the security and safety of the prompts, and later I will show you that we were studying the situation how to prevent our solution that is LLM-based from being hacked by using stupid or wrong or bad prompts. Another part of prompt engineering or engineering in this form is this part that is related with research and looking for other methods. And that's all. That's the prompt engineering, nothing else. It might seem too simple, but it is simple so. There's nothing more beyond those two things. So I think that if you are asking or thinking, doesn't make sense to have a prompt engineer in my company or in my business, the answer is maybe not so clear, because I will not give you the answer. Do you need a prompt engineer or do you need to hire a prompt engineer? However, I think that every team that is going to use LLM as a part of their solution should know at least some basics about prompt engineering.
How do you find basics? Exactly.
How am I defining basics?
Yeah, basic knowledge, because we are not very basic.
Yeah. I think that this presentation is about basics, I would say. That's my journey through the.
Really. I have experience with the people from big corporations, and this will be very hard to comprehend for them. For most people.
Will be what?
Most, it will be hard to comprehend, understand.
All right. Okay. Good. Let me continue, and then I will try to answer your question, maybe during the break. All right. So the challenges that we were facing was how to eliminate hallucinations, how to prevent from jailbreaking or prompt ejection attacks, etc. And the most interesting part for our type of company was how we will create a chatbot or LLM-based solution that will be something that is responsible only for one task and will never go out of this scope. So in other words, if you will ask the bot to give a joke about DPD or other company, he will answer you, I'm sorry, I'm not going to talk on this topic because my goal is to do that or another action. And my question to study this topic, and maybe this is the answer for your question, was how far I can go with prompt engineering to achieve or to face all of those challenges. And this is the area I would like to continue this presentation to you. All right. I'm not going to be boring, as I said. So all the techniques that are available to you, I prepared as a Airtable. I collected 28 that are worth of attention. And I decided that remaining 30, because there was something about 60 techniques, remaining 30 is a waste of time. So this list is only a list of techniques that have scientific proofs, that have results that are meaningful, Sometimes the technique is very simple, sometimes the technique is very theoretical, and realization or implementation is quite useful. However, it doesn't mean that it's simple to implement in your solution. So, in other words, I'm not going to go through every prompt engineering technique. I gave it you as a takeaway from this presentation. You can study it by yourself by reading the papers. I was reading them last few weeks just to prepare for this presentation well. And I observed a few things that might be interesting for you. I'm not, I don't know what are your projects, but in my projects I was creating, I was asked by my potential customer, I was looking for techniques that will solve the problems that this customer was facing in his business. Okay, let me play some game with you. It will be very simple, just few myths or facts. One thing, GPT has changed a lot, making most prompt engineering techniques useless. Is that true? Is that myth or fact? There was myth, myth. You think it's a myth, all right? Good answer, but it's not so easy. Why? If you will take, for example, chain of thought prompt engineering technique, this technique is very useful. It has results. It has a lot of scientific proofs and practical proofs that it is working. However, if you compare, for example, GPT, maybe that's the best LLM model at the moment on the market, you will see that you no longer need to add this explain step by step to your question, because probably almost always it will add it by default. So this technique is of course important for us because we need to understand how it is incorporated to the solution that we are using if we are using OpenAI GPT model, but it doesn't mean that we need to use this technique directly. The other story is if we are going to use other LLM models and there is no such solution incorporated by default to this solution, to this model. So that's the reason why the answer is not so easy, because the techniques are of course somehow useless because they are already embedded in the solution that we are using, but it doesn't mean that we need to forget these techniques. Sooner or later, we will find a case when the model didn't understand what happened and is trying to give you direct answer without reasoning. And then it is better to add this explain by step, for example. Another myth or fact. Using appropriate prompts, AI hallucinations can be avoided. Myth or fact?
Not so easy.
You got me. Applause for him. Yeah, that's the hero of today. What's your name?
Leap.
What?
Leap.
All right. I cannot repeat, but maybe later. I will learn. I promise. Okay, the answer is not so easy. Actually, there is no prompt engineering technique that will guarantee you 100% sure that there will be no hallucination. If you will think for a while about large language models, this hallucinating is the heart of this concept. Whatever type of string you will provide as a prompt, the goal is to continue this text. Even if you don't know the answer, LLM will try to find the answer. Sometimes we'll try to find fake answer, but still true. Sometimes it might be hallucinated untrue answer. Happily, last version of GPT started to answer, I don't know, sorry, I have no enough facts. I have no enough information to give you good answer. And if you will try to, for example, write something like strawberries are the best keys in the keyboard for advanced developer, then ChatGPT will answer you. It seems that it's something that I don't know. Could you explain me more about strawberry keyboard or strawberry keys? Anyway, there is a solution for hallucination, for avoiding this situation, and here is the... What?
Some guardrails you do here.
Yes, yes, it's based somehow on guide rails. However, the idea, I would say, is more generic. And I will show it on the next slides, because this approach, when you are harnessing another LLM model to evaluate the answer, to evaluate how probably the answer is a hallucination, this solution might be good hint how to deal with all of the problems that we have with LLM-powered solutions. Another question, is it possible to create a prompt that is jailbreak or prompt injection safe? All right, nothing new. One interesting approach to this type of, let's say, attack or disadvantage of LLM-powered solution is Geiger run or Geiger. I don't know how to pronounce it in English. I'm not a native speaker. And Geiger is something that will analyze the prompt before it will be sent to LLM, just to identify something that might be wrong with the prompt. Okay. And anyway, as you can see, they are very honest and they are not promising anything. The strategy that they are giving us is, if you don't have anything to verify the incoming question, it would be better to have anything to analyze it. That's the best strategy. The better you are with analyzing incoming prompt, the better chances are that you will identify some prompt injection or jailbreak attempt in the prompt text. Okay, so how to deal with all of those problems? We observed, as I said, as you observed as well, that there is a kind of pattern. Then this pattern might be applied in all LLM solutions, because whenever you try to resolve serious problems using prompt engineering, you will land with no solution. You will land with a solution that is very weak in terms of being, prompt injection or jailbreaking or hallucination safe. So we started to think about architecture of LLM solutions or LLM-powered solutions in two ways. One is direct chat, another is, I called it integrated solution. It's a type that somehow is a wrapper around LLMs and give you more control over the conversation or over the using LLM. And it seems that those integrated solutions might be something that we should go through if we want to continue our project in terms of building focus AI robots that are responsible for the given tasks and are not doing anything else, only the thing that we are expecting them to do. Here, this table shows you something very simple, but I think it might be useful because there are, in the table I provided earlier, there are some techniques that are very simple, and you can use them, as I said, quick and easy. It means, for example, direct stimulus technique is a technique that you are giving the question and you are attaching few keywords that you expect to be used in the response. And this direct stimulus technique is quite useful if you have no time and you want just to ask a question. Yes?
You have fact-checking and the recommendation do not do this. Why? You elaborate more
Yeah.
about
Yeah, I was expecting that someone will ask why. About fact-checking and using LLMs, there are better solutions for this kind of activity. Fact-checking is part of journalism, art or craft. And fact-checking means that you cannot go with automated approach to this problem. You need to study it carefully, because even people that know almost everything are very, very weak in identification of fake information. So I hope so that one day we will find a solution that will be, fake news detector, and it will be based on LLM solution. However, for today, that's something like, cleaning floor or repairing cars. It must be done by people. That's the answer. Are you okay with my answer?
Sure.
Thank you. Thank you. All right. As you can see, here I'm showing some kind of symbol, a code for representing some mechanism, because I think that whenever you think about LLM solution, and it will be or it must be a reliable thing, a thing that will work for example, for a bank. It must be something that will be controlled by you. It must be something that you will trust. You will, or your customer will say, all right, this kind of chat I can deploy on my website. I'm not afraid that this kind of chat will answer stupid questions or give stupid answers to right questions. And as you can see, LLM solutions type 2, I mean those integrated type of solutions. I see that when I was studying the list of prompt engineering techniques, I found that there is one pattern that is repeating every time when you are trying to build something that is very safe in terms of being task-focused AI robot. I call it LLM to LLM. This mechanism is very simple, as the name suggests. It's something that you are trying to harness one or various LLM models in order to verify the answer, find the appropriate or the best one, and then validate if it's possible to go forward with this type of interaction. Of course, it will not guarantee anything. However, in our solution, HalGuru, we decided to build with Chris Prusik. We found that just by inserting some kind of, let's say, penalty level parameter to the prompt and going with the prompt, with the response, with the context through the LLMs, through the different sessions with conversation, we can observe that the 2 or 3 LLMs accept the conversation as something that seems like something that we can continue, or we should stop this conversation, change the prompt, and, for example, go with the conversation with our customer to the end of the conversation in terms of, for example, I see that you are trying to talking about jokes and not important things with me. So I invite you to visit my website. That's all. Thank you. Goodbye. And this kind of solution is much better because it works like, like receptionist. Receptionist in every company is a person who, if you will go there and ask for something, the person will answer you, okay, I can write down your number, your name, I can schedule you a meeting, but I have no time to talk to about, stupid things. it's not my role. And the same behavior we expect from the robots or AI robots. All right. It took 30 minutes, or 29 to be precise. I have a riddle for you guys, and I'm not going to answer the riddle. That will be something for you. Do you have any question to me? Do you want to ask anything before I will show you the riddle? Yes?
Yeah, so actually a few LLMs were, I think a few LLMs were listed there. Is the solution you're talking about, do I understand correctly that you filter the input, you ask a few different LLMs whether this is a valid query, and then only then pass them to the main LLM?
You mean a situation when we have a question, and I send the question to, for example, 3 different LLMs, for example, Claude, GPT, and some other, and I have 3 answers, I compare them, and I select the best one?
No, I'm making sure if I understood this correctly, that if you have, in this type 2 solution, do you send the query to different LLMs, check with them if they think whether this is an attack or something, waste of time with our main LLM, and then I'm not sure if I understand it correctly.
Yeah, the story that you described seems like you understand the concept, okay. So I can answer yes. However, if you want to understand the details, I might, I may explain it to you after the presentation during the break. However, that's the concept.
Okay, cool, thanks.
All right, the riddle is very simple. If you get a stupid response from ChatGPT, whose fault it is?
Stupid AI.
All right, thank you.
We will have another session. We will welcome on stage Prince Kanuma, joining on stage. And this time, something about RAGOps. Who knows what RAGOps is? Raise your hand. That's I've stolen one question from him. Stage is yours, sir. Enjoy.
Thank you. All right, hello guys. So today we are going to talk about RAGOps, but not just your typical RAGOps. We are going to go from basic to advanced. But first, I need to understand how many of you have actually tried to play with an LLM, either locally or through an API? Okay, you guys have the idea of it. How many of you know what agents are? How many of you have built a RAG application and shared with your colleagues? How many of you hate yourselves when you share it and your colleagues find bugs? All right, so let me take you to the next level. So today we're going to talk about what is RAG. We're going to go through document processing, prompt engineering, retrieval, monitoring and evaluation, and I'll give you a demo in production. All right, so first, who am I? My name is Prince, and don't worry, my family is not royalty yet. And I'm an MLOps engineer and founder at Kulissiwa, and these are some of the projects that I've contributed over the years. This is all on GitHub, so if you check me on GitHub, you will see all those contributions. And if you are part of these communities, hi. All right, so over the years, I've been building machine learning applications. I started back in 2017. I was super excited after Google announced TensorFlow, and I just couldn't stop myself from building stuff. So first project I tried to build was a style transfer SaaS that actually made some money in India, around 10,000 rupees, something like 250 zlotys. That's a lot of money there, don't laugh. And then I went on to build a speech copilot. I like to give speeches, and I was like, what if I could actually make the script using a large language model? Back then was GPT-2, so I fine-tuned it, and I deployed it to production. I fine-tuned it on the 100 best speeches of the world. There's a book with the top 100 speeches, and I kind of deployed it. That was like my first experiment with it. And then later on, whilst working at Neptune AI, I developed the documentation bot to help support our support team be able to handle all of our hundreds of customers. And nowadays, I'm working on Kulissiwa. And I'll talk about Kulissiwa in a minute. All right, so let's go from rags to riches. Today, you are going to get out of here knowing what to do and why you're doing it. So we are working with foundation models. So we first need to understand how they are created and how they work. So nowadays we know of ChatGPT, which is mostly a text, and if you use the application, you have now vision, which we call those are modalities, and when the model can do both text and image and more types of data, we call them multimodals. So models, that's a mouthful. So we have our pre-training stage where we just teach the model how to predict the next word, how to complete a sentence, and so on. Then we take that model and we do what we call domain adaptation. You know about domain adaptation, but from a different name. You most likely know about fine-tuning. It's kind of the holy grail of deep learning. But we also have prompt engineering with foundation models and retrieval. So in this talk, I'm going to kind of skip fine-tuning because it's expensive. Not everyone has hundreds of thousands of dollars to do fine-tuning. Not that every type of fine-tuning is expensive, but most of it still is. All right, so what is retrieval? How many of you know what retrieval stands for, RAG stands for? So please, there, white shirt.
Okay, sure. Retrieval augmented generation.
As the name suggests.
So basically, when we receive a prompt, we search for information from database or any other source, and put it to the LLM to generate answer to the prompt using this external information.
Absolutely. So retrieval augmented generation helps models like ChatGPT or GPT 3.5 Turbo or 4 stop saying, as an LLM, I don't know, I was trained till 2021 or 2022. So basically what retrieval augmented generation is an architectural approach to help the model increase the efficiency by providing custom data. This could be your private data, your documents, images, and so on. So you pass that as context to the model in the input. So context is just the input. And the model, you either ask a question or you have a task for it to complete, and the model is going to use that external information to provide you with an answer or a particular action. And this helps mitigate first hallucination. You can also provide it access to, like I said, proprietary data. It provides you also with source attribution. So you can now know what the model is using to generate the answer. That is important because you want to be able to verify and understand whether the model truly is performing well or not. And it's also domain versatile. So you don't have to do fine-tuning to be able to use these models to tackle different tasks in different domains, right? So for example, if you're in the medical field and if you are in the law field, you can still use the same model, of course. With time, fine-tuning can help improve the accuracy, but from the start, if you don't have enough data, you can just get started with retrieval augmented generation. All right, so what is the ops part in RAG? Most of you, if you come from the software background, you know that the famous saying, it works in dev or it works in my laptop. That's not my problem. But in this case, we want to be able to integrate the systems with other interfaces. For example, if you have a web application, you have an API, you want to be able to connect that and be able to have a consistent performance. On top of that, I've seen some use cases where people are connecting this to some automations. For example, generating a report that answers a particular question every week. So for example, if you're in the finance industry, you might ask, what is the performance of a particular index, monthly or whatever frequency? That's one of the ways you can do that. Another way is data management. So you will be responsible for handling the data syncing, processing, and the retrieval as well. And finally, you'll be able to monitor your models so you can consistently update it when it's necessary. And we'll see some use cases about that. So now, when you're building a RAG application, there are 3 things that you can think about when you're getting started. First is data. Do you have the data? That's the first question you should ask. Of course, it's not, in some cases, it's not truly relevant because these models are versatile, like we explained before. But if you do have the data, your way of approaching this problem is a bit different. You can gain some performance by having the data. Second is there a baseline? So do you have a benchmark as to what good looks like? Do you have a metric that you can look at and say, okay, if we achieve this metric, this model is performing well, or this RAG pipeline is working well? Then latency. So I've seen some competitors and even people in the space that go towards streaming. But if you really think about it, not every use case requires streaming. If you're doing a report that is like a scheduled job, you don't need streaming. You don't need to make it immediate. You can create a different type of pipeline, a different type of application, and perhaps even save resources. All right, so at the high level, this is what a RAG pipeline looks like. You have your data. It could be public or private domain. It comes in multiple formats, either structured or unstructured. So structured, you can think about it as tables or any information that's in a formatted way like JSON. And then you have unstructured, like images. So we talked about multimodal. RAG can also be multimodal. And the first step you go through is kind of processing that the data. And a common use case would be text splitting. If you have a document with 100 pages, you split that document into different pages, then it could be, that's one strategy. You can split it into pages, split it into smaller sentences. Then you create an embedding. So an embedding, all it is just an array of numbers that can represent that information, that text, in the latent space. That's just the way people in machine learning make things complicated. Just imagine that it's the representation of text. That's it. Then after that, after you have your vectors, you create a kind of vector database, right? Or you use a vector database. But all it is just a table with your content, your chunk, your embedding, and some metadata. Why is metadata important? So imagine you're serving an application with multiple different users, and each user has their data, and you want to keep it private. You might want to use metadata to be able to filter the data so that users don't see each other's data. So that's why it's optional. In some use cases, if your company doesn't have any kind of access policies, you don't need metadata per se. You can just use all the data that's available to you. After that, you just save it to the vector database, and you also pass in your retriever here, your embedding. So what this is, when you see here the retriever is just a wrapper code that takes your embedding, takes your vector database, and whenever there's a user input, a question or a task, it embeds the query, creates this vector, and it tries to find similar vectors using math. And after that, you get some documents, some chunks, and you pass that to the LLM, and the LLM is going to generate a response. So this is just a high-level overview of it. Any questions? Okay.
A question about documents, parsing documents, and
Yes.
images within the documents.
Yes.
Of course, this is tuned to text indexation, right? But
Yeah.
have you had success with like processing charts or images?
That's a great question, and I actually have a slide talking about it. Okay. Now, I created this slide and I wrote the taxonomy of RAG pipelines, but it's just basically some of the RAG pipelines I've seen in the wild. And if any of you follow me on LinkedIn or Twitter, I post a lot about this graphs. Pretty much these graphs just represent the RAG pipelines. And here you will see from the most basic one to the most advanced. So let's go. First is vector search. This is kind of the naive approach. Everyone, when they heard about RAG, was like, okay, let's just embed the data, and then we can do some similarity search, and we can create an answer. It works well for majority of use cases. But what are some of the main issues with this approach? Can anyone tell me? Anyone? Sure.
Sometimes you don't have data in this database.
Okay, that's one. Any other?
There is no context of the conversation.
Not really. You are retrieving similar information, so you would still get that information. But what are some of the pitfalls with this simple approach of just finding similar text?
You will find too much text.
That's one.
Document,
Excuse me?
the same document.
The same.
There's no enough diversity among other documents. So for example, if you are searching for one person,
Mhm.
you will have the same thing paraphrased, like who Albert Einstein was, like in 10 different ways of saying.
That's a good one.
Maybe randomness, scientist you get a cat, scientist you get a dog.
Mm-hmm. That's a good one. All of you guys are pretty good at this. So let's see. So first is limited keyword search. As some of you mentioned, you might not be able to find the particular keyword, or you might be able to find a lot of the keywords, but not really the context that's relevant to the information. This can happen for a lot of reasons. In my case, for example, when I revamped the pipeline for Kulissiwa, I noticed that I had really large chunks, for example, for PDFs. I was embedding an entire page, and I noticed that there was this particular question. The answer is there. I know where the answer is because I read the document, but the answer is in the middle, and there's no way you can find similarity because the answer is in the middle of the sentence. So the one way to do it, to approach this, is by finding a way to not have large chunks, and I will talk about that. Another is multi-turn conversations. So because you are just retrieving similar information, you have the case where the user will say, hi, and the LLM will answer, hi, how are you? And you will say, I'm good, my name is so. And then it would ask again, what is my name? But the LLM already forgot because you're only processing the last query. So, and I'll focus on this in just a bit. And then bad retrieval. So this is the case where your context or the information you feed the LLM is all wrong. Excuse me. And you expect the LLM to return a relevant answer. So how do you address these? One way is to use hybrid search. So what hybrid search is you have your embedding model, your normal dense embedding model, OpenAI, text ADA, or text embedding 3, and so on. But then you have another type of model, it's called BMI 25. It creates sparse embeddings where you can actually embed certain keywords. So for example, if you're looking for the keyword doctor in your queries, the model the retriever will be able to find those chunks much easier if it has a hybrid search mechanism. But this doesn't necessarily address all of these problems. It addresses number one. But you still have 3 others. How do you guys think we can address the remainder? Any ideas?
Agent.
Excuse me?
Agent-based approach.
Agents, okay. A big knife, actually a sword, to have dinner. But it's a good one. It's been used. Any other ideas?
When we are splitting our information into documents, we can make these documents overlap so that we don't miss any information that is in the middle of the document.
Okay, I see. Some techniques, some naive techniques need overlapping. That's a good one. Any other?
small chunks for the embedding and for search, and then retrieve more context for the answer, right?
Good one. That's a good one.
Smaller is better to search.
Uh-huh.
Chunks, right? Smaller chunks. So
Uh-huh.
like documents from smaller chunks.
Wow, you guys are good. Okay, so let's talk about contextual compression. So there was a paper by Microsoft, and I tweeted about this. I think it went viral, this tweet, but if I remember correctly. So the idea is very simple. You have your vector database, you retrieve your documents, but then before you pass on the documents back to the LLM, you either do one of two things or both. The first one, you pass it on to another LLM or the same LLM with a different prompt where you are asking the LLM to eliminate all the documents that are not relevant to the question. That's one way. Another way is to use embedding filtering. So you'll say if the embedding of the query and the embedding of the document is not as high, you drop those documents. Or you can do both. In the paper, they kind of do both, and it works really well. And I'm actually using this as well. Then we have retrieve, rewrite, and read. This is, I guess, another paper from Microsoft, if I'm not mistaken. But it's another paper. The idea is very, very interesting. And it was one of the first ideas that I explored when I was building Kulissiwa, which is for whatever query I get from the user, I pass it on to the LLM, and I ask the LLM to rewrite that query. Why is this? Have you ever noticed when you go to Google, your first question is not really good? You're like, I wanted something that's similar to this, but it's not really this. And you kind of go through many cycles until you get the right query to answer it. LLMs are very, very good at understanding intent. So they can kind of get the idea of what you're trying to do and say, okay, this person most likely wanted to do this, but of course it's not gonna say it that way. It's just gonna rewrite the query. But why just do that to one query? Why not create multiple queries? You create 3 variations of the same question. Then what happens when you go to retrieve? Instead of retrieving only these 2 documents here that are closer in the vector space to the user query, you can get way more context from the vector database or the retriever just by rewriting the query in different ways. And this can improve your accuracy significantly.
But then do you evaluate relevance as well at this stage? Like there
Yep.
are two different techniques.
We are gonna get there.
Now you get many.
Indeed, you do have way more documents than before, and that can also cause certain problems like context size. If your LLM, for example, only has 4,000 tokens and this is bigger, your application might break. There are drawbacks to this, but it is super powerful.
And I have also a question for previous slide. If you can switch back.
Okay.
And in that bottom line, as I understand, there need to be some threshold
Yes.
after which we need to drop that.
Exactly.
those,
It's just a simple if.
Yes. So, is there some methodics how to find that threshold?
For me, for example, in my case, I iterated between 0.8 and 0.75, and 0.75 was good enough that it wouldn't drop certain, like the extra questions, extra context. 0.8 is fairly high. You have to have really good embeddings for that. So for me, 0.75 worked pretty well.
So do they work for like different applications? That same threshold?
No, you'd have to iterate and test for your own application.
Okay, thanks.
Okay, so you might ask, Prince, why rewrite queries? And actually, I got this question from a friend of mine, dear Hindi hacker and customer. He asked, okay, could you explain why would you rewrite the query history if it exists? And how does the query rewriter work? So, like I explained earlier, imagine this is your conversation. You have your history. You said, hi, how are you? You went through the conversation. And then normally you wouldn't, when talking to someone, you wouldn't start the presentation, like I wouldn't start the presentation from the beginning to go on to the next point, right? So the user would ask like, why is that? But what is that, right? The LLM does not know this. So if you pass on the history and the query, the LLM can now rewrite and say, why is X important, or why X and B behave in a certain way, for example. And this is gonna give you way better performance than you just taking this query, why is that, and passing on to your vector search. Like this will not work. Why is that what? So you will get this that is another context that not even relevant to what the user is asking. Okay, so someone asked about retrieval scores and relevancy. So this is where you can use re-ranking. Cohere, I have a friend that works there, Cohere, great company. They have a really great API for a re-ranker, and it's pretty fast. I tried it myself. So my customer asked, okay, should I use a re-ranker, yes or no? And my answer was, well, it depends, because they can be slow, but actually these guys are pretty fast. And at the same time, I had a lot of questions myself about this because I don't use it. So I said, okay, let me research about this and understand it better, how it works and how it would be better. Here's one use case where the user query is gonna be sent to the vector database. You're gonna get your documents, and here you can increase the K, the number of documents that are returned. You can have like 10, which would give you a bigger surface area to work with. Then you pass it on to the re-ranker with the query. The re-ranker is basically an LLM that's gonna take the query, is gonna check the documents and give the relevancy score to each document. And then you can use that relevancy score to filter out some of the documents so that only the top relevant documents are returned. This way, if the user asks a question, it doesn't get 10 sources, it only gets like 2 or 1 source that is relevant to the answer. Okay, yes?
Just a quick question. You said that you're using LLM for re-ranking, or this Cohere is using LLM for re-ranking. But is it kind of heavy or too heavy? Like, there are some models for ranking from what I know. I don't know if you use any of them.
Yeah, well, it's a custom LLM that they fine-tuned particular for this. And I don't know the architecture of this LLM, but I believe it most likely doesn't have the normal kind of structure as a normal text generation LLM. It just generates the relevancy scores with the documents. Yes?
Similar, the technique is similar to, for example, dynamic ranking technique that, I don't know if familiar, Algolia search is using right now. I'm not sure if you're familiar with this kind of solution.
I wouldn't know. But there are some open source options for this. I think Colbert is one of the models that does this. And you can also use an open source, a trained, kind of fine-tuned model to do this. You don't have to use their API. I just think that their API is fast because they are running the GPUs for me, which is cheap. Okay, so you have the extra documents, you filter out, and you get great results. And this is much better than, for example, just doing relevancy scores, because you can actually get it's better than doing similarity search or vector search, because you can actually get only the top documents as an input to your LLM, so less distractors. Another one is multi-document agent. So someone talked about using agents. This is a very interesting approach that Llama Index, I guess, is doing. And of course, you can also implement this on your own. But here's one way I would think about this. You have your input query from the user, you rewrite it, and for each query, you have a specialized agent that is going to take that query. Example. Actually, this is an example from Llama Index. You have a document, for example, Uber's returns or investment portfolio, whatever. You have an LLM or a function call that is specialized to catch only that query. Uber information, you use this agent, and that agent has a particular namespace or a separate vector database that it can retrieve information from and then you combine the information from different agents. At the end, you get these documents and you create the answer. That's one way. Another way would be to have each agent answer the question and then have a summarizer at the end, another LLM that just summarizes all the responses from each agent. The problem with this is that it's expensive. You are running an LLM here, you're running an LLM here, and you're running an LLM here. So you're pretty much you're paying 3 times the amount of tokens just to generate the response. It's good, it works. If you have the funding and the money, go for it. Oh, so any questions here? Any questions? Sure?
Do you rewrite the queries with the context from a previous conversation, or
yes.
do you just rewrite the query basically just with the context of that query?
I'll be spilling some beans on secrets I use. So basically, what I personally do, if there is a history, if it's not the first question the user asks, I rewrite it. If there's any history, I rewrite it. If it's the first question, no need to rewrite because you don't have any context. You can still rewrite it to potentially improve it, but sometimes because of the lack of context, the LLM might infer something that's wrong. So if you're rewriting all the queries, the user might be asking something and not getting that because you are rewriting the first query. But if it's the second query, you can rewrite it. Yes, please.
Do you cache the answers for the rewritten queries?
Do I?
Do you cache the answers, not to query again the question from another user is the same?
No, I don't use I don't kind of use cross history across users because each user has their own private data. I wouldn't want to find queries that are common across them and use and kind of cache those because you don't know. You could be the answer could, since the answer has a context that's relevant to the user or documents from the user, you are pretty much exposing information. So that's not good. But if you're running an application that doesn't have those privacy concerns, it's okay to cache similar queries. Hopefully I answer your question. So now, this is the one thing that actually blew my mind. It's called the parent document retrieval. LangChain has this implementation. How I came across this is a very interesting use case. So I talked about the question that I had that was in the middle of the page. And since I embed the entire page, when I do retrieval, it wasn't working. So parent document retrieval fixes that. Yes, if you do hybrid search, you might get it, but parent document retrieval helps because you create chunks. For example, we have I will show this. So basically, you have an input, and each input returns certain chunks, right? Certain documents, and each document is matched to the parent that it comes from. For example, you can imagine that this is a section within a page. So since we caught section 1 and section 2 from page 1, we return the entire page. So now, because you kind of can infer that the question that the user is asking is within that page, right? So if you return the entire page and you have a powerful model like GPT-4, for example, it will be able to find the answer better than if you are just returning that chunk, because that chunk could be the most similar to the query, but doesn't contain the full answer, right? And how this works, actually I made this and I tweeted about it and posted on LinkedIn. It's a very interesting mechanism that I think people should know. So we start here with the full page or document retrieval. Basically, you have this page, and this is actually the page that was giving me a lot of trouble. The context I want is here, is in the middle. But relevancy search, how do you call it? Vector search only gets, for example, the top or some of the bottom. It has a hard time catching here in the middle. So what you do, you create chunks, and each of one of these child chunks is kind of referring to the parent chunk, which is the entire page. But you might have a different use case where You don't want to return the full page. And one thing that you can do is that you can create chunks, and those chunks have smaller chunks, right? And whenever you kind of get the small chunks, you return this particular section instead of returning the entire page. So these are two ways of doing this. And on step 2, basically you're doing just similarity search. You get different documents, different chunks, and each one of those chunks is kind of referenced back to their parent, and we return those parents as the context. Any questions?
I have a question, please. Because
Sure.
I have a question how you embed this. So only parent, only child, only grandchild, or everything?
You can embed both parent and child, right? So that if you want to kind of include the parents in the context, but LangChain does this in a very interesting way. It kind of just IDs the parent. You kind of create chunks of the child's, right? Or this child, you create embeddings of this child's, and this child's already referenced back to the page. So that's one way you can do it. You save money. You're not doing double embeddings, but there's another function that it calls multi-query, not multi-query, multi-vector embedding, something like that, where you are creating two sets of embeddings for the same document, right? That way it might help you catch more things, and since embedding is very cheap, you're fine. But personally, I think for my use case, I actually tested just this instance here of the full page already solves the problem. And that was the only problem I kind of noticed, yes?
How do you time them so nicely?
Come again?
How do you time
How do I?
text? How do you time this text so nicely?
Oh, so we will talk about chunking, but basically there's a lot of ways of doing chunking. Most people just chunk based on new spaces or a particular kind of structure of the document. And I prefer the kind of semantic structure of the document. So in this case, this document is properly sectioned because you're not creating a chunk here. You're creating a chunk of the entire kind of section, which is better if you're doing retrieval augmented generation.
What if the text is not formatted so nice?
Oh, well, I thought about an idea for that, and my idea was try to find a way to convert it to Markdown or have an LLM rewrite it to Markdown. It's expensive, but that was my idea. Like rewrite it to Markdown and then use a Markdown splitter. And if you can have your documents in Markdown, better. I think in the future we will have better kind of better ways of doing this. They are cheaper, but at the moment that's what I thought about. Perhaps there's a better idea out there. I would be happy to hear. Yes.
So do you have like only one level of dev, or there might be more levels?
Yeah, there might be more levels. These are the 2 levels that I saw that they implemented, but I think you can create your own and kind of go create deeper levels.
How would you determine whether it's that you should start or go deeper to create more levels?
I think that is basically through experimentation. That's why machine learning is beautiful. You experiment until it works. Like 0.75 is very arbitrary, but it took a lot of experimentation.
Okay, I see what I continue.
Okay, but you can ask your question.
No, I just wanted to say that we were trying to do something like I think what one of you asked. So trying to chunk by the context, right? So we and I found some article when there was a guy who proposed some algorithm where you calculate embedding for every single sentence, and then you like iterate over the sentences, and you calculate the distance between.
Yeah, that's also
like a context change.
Exactly, and then you can fuse the embeddings of those different sentences.
Well, really, you can have this paragraph.
Absolutely, that's a good idea. I'll think about it and see if I can implement it. So you have document processing. That's kind of the first thing you're doing when you're creating your RAG. And there are 3 things that I think you should think about. There is more, but there are 3 top things that I think you should think about. First is beware of your splitting strategy as we are speaking. If you just naively split your documents, you're gonna get really bad chunks, and when you run retrieval on those, it's not gonna work. Because the particular chunk you retrieved, it's probably similar semantically, but it's not really the full answer. Second is like the chunk size matters. If you create really big chunks like I did, you'll have problems. You won't be able to retrieve, and we already talked about this. And the final one is handling edge cases gracefully. So PDFs, for example, are not exclusive text. Some of them come with tables, graphs, and so on, and all of those tables and images, you can kind of classify them as the top edge cases. And I think here to solve this, you should have conditions where you're checking for images in your documents, or checking for tables and finding ways to embed those, or creating completely separate pipeline where if you identify any of these items in your document, you create a kind of a pipeline, or you tell the user, you inform the user that we are not going to process table X, Y, and Z, or the image X. Next, we have prompt engineering. We had a great talk about prompt engineering, but here are some of the top things that I learned. First, models behave differently. So in Kulissiwa, we have GPT-3, GPT-4, GPT 3.5 Turbo, GPT-4, Gemini Pro, and Mistral Medium. And the same prompt that worked well with the GPT families of models, it did not work whatsoever with Gemini Pro and Mistral. They were failing miserably. So I iterated on it and found the common prompt that worked. But it doesn't mean it's the best prompt in the world. It just works for my use case. Then you have explicit instructions. So it's better to say use bullet points, return JSON only, than yeah, I want you to format the answer nicely, right? So be more explicit in your instructions. Another one is, if you can, use few shot. So give an example of what you want it to look like, or the answer to look like, to the model, and these models are pretty good at understanding and picking up those ideas. Even if it's just one example, two examples, test out and see how many examples it takes to teach the model a new behavior. Then finally, it's like emphasize, re-emphasize if you can. In my prompt, for example, I have a part where I explain the model what to do, and then at the end I say remember to do the same thing. I know it's a bit repetitive, but because of that remember tag, the model can kind of understand. And I found out that having the instruction at the top and towards the bottom, it kind of helps the model behave better in my use case. Then you have retrieval. If you can, go SaaS. It's pretty much free infrastructure management. They are gonna manage all of your infrastructure. For example, I use Supabase. That's where I store all my embeddings and my documents. It's easier. I don't have to create my own instance and manage that instance and scale it. It's easier if I just use that. But if your company has enough money to burn, go ahead and go on-prem. Then you have latency. Ensure the latencies, the responses are as fast as possible for the use case. If it's batch and is set to be delivered at 9 a.m., it should be delivered at 9 a.m. If you're creating a chat interface that the user needs to get the response immediately, try to see if you can implement streaming, for example. And then scalability. So make sure that your pipeline, your entire RAG pipeline can scale. So let's say if you increase the number of queries that that your vector database is getting at a particular second, how will it behave? If you use bigger embeddings of, let's say, 2,000 dimensions, how will it behave? And here are some of the examples of this. So Supabase released this article where they talk about serving 1 million embeddings of 1,536 dimensions. That's just pretty much 1,536 numbers, and each using of the 1 million embeddings using Postgres PG vector extension. And you can see here that they are better than Pinecone. They can serve 780 queries per second at 99% accuracy compared to Pinecone. And a clear example of this is where I think some of you, if attended my previous talks, you can see that I was actually benchmarking these technologies, and initially I was using Modal Labs with Pinecone, then I switched to Vercel and Supabase, But it turns out that Vercel and Supabase it actually took longer. It took 12 seconds to respond, because out of these 12 seconds, 6 seconds it was taking to retrieve my documents from the vector database. And I was like, that's odd. Why is it taking 6 seconds? I'm indexing my database with HSNW, which is a technology to kind of make things faster. And I kind of switched to Cloudflare to test it out, and I got my overall response latency to 3 seconds. That's incredibly fast. It's faster than you can even type. So I got these results by migrating from Pinecone to Supabase, Model Labs to Cloudflare, because Model Labs, the problem was that it took 2 seconds, 1 second to 2 seconds to start up the container. And Cloudflare, since its edge functions is JavaScript runtime, it pretty much starts instantly. There's no wait for startup times. And I got my accuracy to 99% and under 5-second latency. So now, finally, monitoring. Here we have, there are a couple things that you should think about when you're doing monitoring. First one is 4 golden signals. This is, I think, an article that Google published. These are the kind of metrics that you should be looking at: your latency, your traffic, errors, and saturation. You measure these, you're up to a good start. Then you have user feedback. Thumbs up, thumbs down. But it turns out if you include this in your application, most users won't do it. The users that will do this either love your product or are very good people. Not that everyone else is not, but it just takes a different kind of person to do thumbs up, thumbs down. Then you have performance for each step. Be able to continuously monitor and track how your pipeline is performing at each step, right, of the generation. Then you have app usage. How are people using your application? What type of queries are they asking? Are people coming to ask questions that are just out of context with their documents? Is that kind of an education problem? What is wrong with the way things are going? You kind of should monitor these.
How do you evaluate this app usage?
Personally, at the moment, I'm using Mixpanel. I just deployed it last week, and it's been amazing. I've been seeing people ask, like, generate JavaScript code, and I just understood that, oh, this person is not well educated with the application. Either I have to improve onboarding, or I have to kind of be able to show better the application flow so that the user can understand what to do. So you'll be able to see this information by doing that.
Can you repeat the name? Sorry.
Mixpanel. So here we have Langsmith. Here you have Langsmith traces. It's great for understanding how your application does step by step. Here you have, for example, here's how long my application takes to get the vectors. It's around 2 seconds, but then most of the time was spent on retrieving information for Mistral. Like Mistral takes a long time to generate answers, for example. But the application overall is pretty fast at running. So you could try Langsmith for this. It gives you all the information about your application. In terms of evaluation, there's a very simple idea. 3 things you could do: either evaluate manually, use an LLM, or use both at the same time with human in the loop evaluation. You can go to this repo here. You'll find all the code, and I'll upload this in a couple of days. Right now, I'm fine-tuning Phi2, a model there, so all the information that you need around LLM-ops you'll find there, and I'll include RAG in a few weeks. And finally, there is Kulissiwa. Here's Kulissiwa answering a simple question: what is Tesla's income for 2022? It answered correctly and also attributed the sources, so you can see the source number 1 is the one that used here, and I built this on my own. 4 things to think about. Finally, infrastructure management. Be able to, if you are using SaaS, it's better. You don't have to think about scaling and latency. You can put that load on the infrastructure company. Then modularity is key. Any parts that you saw in the pipelines I demonstrated today could be swapped out, or you could create your own hybrid infrastructure or your hybrid pipeline. Finally, iterative deployment. Make sure that you are continuously improving your application, and if you have the data, fine-tune it. I had this one more thing. So Kulissiwa right now is loved by 100+ people from top companies like NVIDIA, Neptune AI, and so on. And this is a graph of our active monthly users from last December. And we are currently raising funding to build Kulissiwa Smart Onboarding, which is a application to help SaaS companies create better custom onboarding flows for their users. Onboarding is a very hard problem, and a lot of companies have been reaching out, and we are now raising because, yeah, the infrastructure to build this is massive. It's not only LLMs, it's way beyond that. And here's the Loom video. I will share the slides, and you can check the Loom video through the slides. And that's a wrap. Thank you.
Small summary.
Maybe you can thank people from the live, because
Yeah.
we had always almost 200 people.
200 people. Oh my God, and double mic. Thank you everyone online for joining us. We really appreciate that you spent some time with us. Hope it was well heard and well visualized. Enjoy your evening. We will still enjoy pizza. We don't know how to virtualize it and send it over the TCP/IP to you. Sorry for that, but just join us next time on site. We strongly recommend. See you next time.
AI devs. It's in the game.